In this lecture, we will learn about minimum spanning tree. So minimum spanning tree is a very important concept in graph theory where you have basically to make a tree, a set of, basically you have to choose a set of edges that join all the nodes of the tree. Okay, so let's take for example a graph G, V, comma E. So where these are the nodes 1, 2, 3, 4 till 8, 9, and you are given some edges. Okay, so let's assume that these are some cities and the government want to join, make roads, okay, to join all the streets. Okay, but of course we want minimum cost, isn't it? We want minimum cost in constructing roads across the cities. Okay, so what will happen, that I have to join, for example here 9 of the cities. Okay, and I have to use the minimum number of edges to join them. And of course, what are the things here? We want that all the cities are connected. So if there are n cities, okay, if there are n cities, so very simple example, if there are 4 cities, now if you have to connect these cities, so how many minimum number of edges are required? So 1, 2, 3. Okay, so these 3 edges are enough to connect all of them. Okay, even though they are not all very much closer to each other, but at least I can travel from, let's say, node this to the last node. Okay, so similarly here I have to choose some edges, and if there are n nodes, you will find that n minus 1 edges are enough to connect all the nodes. Okay, so we have to choose n minus 1 such edges, okay, which will connect them, and we don't want a cycle. Okay, we don't want a cycle, because what will happen if I join like this? So I can go from here to here using this path, but I already have a path here using which I can go. So a cycle is unnecessary, okay, while we are connecting all the cities. So if we try something here, okay, so what will happen here is, let's say I want to join, so I will choose this one, then 2 to 3, 3 to 4 edge I select, so 4 to 5, 5 to 6, 6 to 1 I cannot select because it will make a cycle, and I can still travel from 6 to 1 and 1 to 6 via all these edges. So what happens, but still I have not connected nodes 7, 8 and 9. So let's say that I choose this one, so it's 9 now connected, and then I can even go to 8 via this one, and then to node 7 via this. And now if you see, so how many edges are there? 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 edges, and we see that there were 9 nodes. So 8 edges are enough if we choose in good manner. So 8 edges are enough to connect all the cities. So I can, if you choose any 2 cities, let's say 7 and 3, so I can go from 7 to 6, 6 to 5, 5 to 4 and 4 to 3. Okay, so this you now understand that we have to connect all the cities and we don't want a cycle here. And here all the edges were assumed to be having same weight. Okay, but what happens if they have some weights also? Okay, so for example, if this is 3, this is 7, 6, this is 25, this is 36, this is 1, 2, 3, some weights are given to each edge, then we want a set of edges, n minus 1 edges, whose weight is the minimum, because that will give us the minimum spanning tree. So you can have multiple spanning trees, okay, multiple spanning trees, but we have to find the spanning tree with minimum weight. Okay, so we will here look at an algorithm known as Kruskal's algorithm. Okay, so let's see what it does. So the main idea with the Kruskal's algorithm, so this is one greedy algorithm. Okay, so this is greedy algorithm which always chooses the best thing that is available to it. Okay, so what happens here is, so let's work it out. So this is a graph that is given where you have the weights also assigned to the edges, and now I want that I should find the minimum spanning tree out of this graph. So there are how many nodes? A, B, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 10 nodes. So now what happens? I want to connect all the nodes with minimum weight of edges. So what we do, so if we are using a greedy approach, so what comes to our mind is, let's sort the edges, isn't it? So again, first thing is we should also sort the edges, and we should choose the edges. So we have to choose n minus 1 edges. So let's start with the smallest edge whose weight is the lowest. So if we sort, so what happens? So let's sort the edges. So it will be, so 2 is there, 1 is there. So let's assume that we sort. And in sorting, so if you have e number of edges, mod e, then it will be e o of e log of mod e is required for sorting. So now what happens is, let's sort, and then what we do is that we build a forest. Okay, that is, we make some sets. And what is that set initially? It is all the vertices are now set. So this is what we do. For A is our minimum spanning tree set, and it is initially a null set. And then what we do, for all the vertices V in the graph, we make set V, that is, we make a new set for all of them. Then sort the edges in non-decreasing order. Okay, so we sort, and then what we do, so for each edge UV taken from the set E in non-decreasing order by weight, so what we do, we find if the set of the endpoints are same. If they are same, then we should not include them in our minimum spanning tree, because that will form a cycle. If not, then we should include. So let's try to see from here with the example that will make it much more clearer. Okay, so let's see. So if we have here, so I make sets A, B, C, D, E, F, G, H, I. So these are the sets. So 4, 5, 6, 7, 8, 9 are there. So we make set. So these are the sets. And then what we do is that we sort the edges in non-decreasing order, and then we take the smallest edge first. So which is the smallest here? So this one is the smallest. So we take this one. So now this one is chosen. This one comes under our A. Okay, so this now comes in A, the edge HG. So let's have this. So A has now H comma G. So this comes here, and why it came? Because now let's see. So we chose the smallest one first in among the edges. find set u and find set v. So it basically returns what set it belongs to. So if we see h and g, so h is now a different set and g is a different set. Okay, these are the sets. So h and g are different set and their sets are not the same. So I can choose this edge, which is a safe edge, and I include it here. Then what happens? So it now comes in A. Why? If you see the code, so if the sets are different for u and v, then A, that edge is added here, and then what we do? We also do union u comma v. So what does that mean? Now I have g and h. So they were different sets, but now I make them a same set. So let's make them a same set here. So this is the set now, gh, and h is now removed. Okay, so h has gone. Now gh is a different set. Okay, so what happens next? Again we have to select the next edge, smallest edge. So we see that we have 2 here and 2 here. So let's take IC. So we have this now, IC we took, we select IC, and again I and C. So I and C are in different sets. So we can select it in our spanning tree. And then what happens? I and C now, so we have them and they are joined together. Okay, so this happens and this is gone. So we have now a same set IC, and this is added in the minimum spanning tree. Then again if you see, the next one which is the smallest edge is GF. Now if you see GF, so G is in this set and F is here, so they are in different sets. So I can again add G comma F, and G comma F, so it can be added here. This will be gone now. So GF comes here and it is also added in our minimum spanning tree. Then what happens next? We again see which is the smallest edge, and now we find that we have this CF is 4, then AB is 4. So we can take that one, and again C and F. So C belongs to this set, F belongs to this one. They are not the same set, so I can include that also. So I should now include CF. Okay, so CF is included, so they now become the same set. So let's have here C comma I is included here, and this goes away. So now let's clean it a little bit. So now we have CF here. So this is the condition now. So next what happens? Again we see in the, so CF is also included. So CF is there now, and then we can take AB also. Okay, so AB now also they are in different sets, so I can join AB. Okay, and A comma B now falls under the same set, and this is gone. So A comma B also comes in the minimum spanning tree. Then what happens after this one, which is the smallest, 7 is there, HI, and CD is also 7. Okay, so HI, so H, G is taken, so HI we can take, or we can take CD. So let's take CD first. Okay, but you can choose any one of them, so randomly. So CD if we take, so now C and D, so C is here, D is here, so they are in different sets, so I can have them. So D comes here and CD also comes in our minimum spanning tree. Okay, so this happens, and now you see we have less number of sets. So now if you see, can I take HI? So H and I, if you see, so H and I both are in the same set, and what happens, this line if you see, So hi now comes, find set of h and find set of I, they are in the same set. And what is happening is, if you join this, it will form a cycle, okay? And in a minimum spanning tree it is acyclic, so we should not include a cycle, so it is rejected. So this is not taken. So after this one, which is the next one, BC and AH are there. So we take AH, A and H. So A and H are in different sets, so we can take A and H and join here. So if AH is joined now, so this comes here, A comma B comes here, this set is gone, so AH is there, and now AH also comes here in this one. So what happens now, we have AH also here, and then if you see, so how many edges we have got? 1 2 3 4 5 6 7. Okay, so we have got 7 edges, so still we have to choose a few. So if now we come to BC, so what happens to BC? So find set of B and find set of C. So B is also here and C is also here, so it means if you choose this one, it will form a cycle. And in fact, you see, if I join BC, then it will be forming a cycle. So we don't choose this one. BC is also not chosen. Then what happens now, after 8 we should look at 9. So DE, so can we join DE? So D, this set, it belongs to this set, and E belongs to this, so we can join them. So DE is chosen and E also comes to this one. Okay, so now DE is also here. Then what happens after 9, we have 10 here. EF can be joined, so find set of E and F are same, so we cannot join this one. Then what happens after 10, we have 11 B and H. So B, find set of B is also this set and H is also this set, so we cannot join them, they are the same, it will form a cycle again if you see. So this is also not joined. So now what happens next, after 11 you have 14 DF, and D is here and F is also here, so DF also, you see, if we join, it will form a cycle here. So now you see that we have run out of all the edges. So our minimum spanning tree 1 2, so how many edges are there? 1 2 3 4 5 6 7 8. So how much? So 8 are there, 8 edges, and you see that 8 edges are should be there in 9 nodes. Okay, so this forms. So now let's look at the code a little bit. So initially the set A was null, which was the minimum spanning tree set. Then what we did, for each vertices V belonging to VG, we made a set, and that's what was done here. A B C D E F G H till I was there. So they were initially different sets. Okay, then what happened? Then we sorted the edges in non-decreasing order, and then what happened for each of those edges? So what we started to do, find set of U, is it equal to find set of V. So if this is so, then we don't include it, because if they are in the same set, it will form a cycle, so we never included them. But when the sets, we found sets were not equal, then we also made the union of them so that it merged into a new set. Okay, so this was the idea behind minimum spanning tree using Kruskal's algorithm. And you see that now what is the weight of the minimum spanning tree? So it is, if we take like this, so HG is 1, IC is 2, GF, so G and F, where is it? So GF is 2, CF, so CF is 4, and then AB, so AB is 4, CD, So CD is 7, and then you have AH. So AH is 8 plus this is DE. So DE is 9. So this summation will be the weight of the minimum spanning tree. And now just try to look at why this algorithm works. So first thing is that it is a greedy algorithm. Okay, why? Because every time when we are choosing an edge, when we are making a choice, we are choosing the smallest edge that is possible, and because that way we always have a sum that is minimum, we are including edges. We had to choose n minus 1 edges. We started from the smallest, and what happened, we chose the edges which were not forming cycle. We included all of them. That's why it gave us the minimum spanning tree. Okay, so that ends this lecture. Thanks a lot.